Hello, everyone. This is Professor Jeff Wilkerson at Luther College, talking to you once more about what to see in the night sky. This time we're going to talk about the week of December 7th. So, what to look for there. If you watched the video last week, and I'm sure you did, I don't know why you wouldn't have, I told you that often I talk about things that are different from what other people are suggesting that you look for in the night sky. And I suppose there are a few reasons for that. Um, One is probably just a general contrariness streak to say, well, I want to just do something that's a little bit different. But two is I also like to talk about things that are related to the classes that I'm teaching and that are in fact historically important, that have some kind of interest beyond just their visual appeal in the night sky, that something that's special for me. And that's certainly true of the things we've talked about the last few weeks. Um, and the third thing is, if everybody else is talking about it out there on the internet, there's really no need for me to be talking about it, right? And so I figured for all of those reasons, I like to talk to you about things that are just a little bit different than maybe you're hearing in other places. And all of that is a lead in to say this week I'm going to talk to you about something you can read about everywhere and that everybody else is talking about. And that's the Geminid meteor shower. And the Geminid meteor shower isn't going to happen. You can find Geminid meteors for a little while um, leading into the peak. But the peak of the shower isn't going to happen until overnight on December 13th into the 14th. And so Sunday night, the 13th, into Monday morning, the 14th, is the best time to go look at it. So we could probably have waited a week to talk about this, but I want to give you a little warning and a little lead in. And the reason I like to talk about this is my favorite meteor showers, and I try not to miss it if I can every year, at least catch a piece of it. And so I want to talk about this, even though it's something you can read about other places, and other people will be talking about it as well. And so what happens is in a meteor shower, meteor showers come from, typically come from, they happen the same time every year. And the reason they happen the same time every year is as we orbit, we intersect the debris that was left over by a comet typically. And so that comet's orbit intersects our orbit, and as the sun boils stuff off that comet, that's what you see in a comet's tail and a comet's coma. You see the stuff that's being boiled off of the comet, and that's dust and debris and grit that's left behind. And so you picture this as a tube of grit and material that's in the comet's orbit that the Earth catches up with and passes through. And sort of we have different trajectories, different directions of our orbits, and so we intersect that orbit, and that stuff enters the atmosphere and burns up, and we see streaks of light as that stuff burns up in the atmosphere, and those are our meteor showers. These are distinct from random meteors on any given night, and I recommend try that this week. Try that before the meteor shower on the 13th and 14th. Go out during the week and just watch for 15, 20 minutes or an hour, whatever you can stand, however cold it is, wherever you are, and just look up and see if you can see random meteors. You should be able to see if it's good and dark, and the moon won't be too much of a problem in the week ahead, and in terms of flooding things out with moonlight. You should be able to see random meteors, and these are meteors that come from all over the sky, and you should be able to see several of these an hour, a handful of these per hour. So if you wait for 20 minutes, you ought to be able to see a couple of these. These are things that have been kicked off of asteroids when an object crashed into an asteroid and threw stuff into space, or it's just that random debris that's left over from the formation of the solar system. All of the terrestrial planets, for example, Mercury, Venus, Earth, Mars, formed with planetesimals, with big rocks crashing into each other, and sort of there's just rocks flying around that form these inner planets. And some of that material is left over, and every now and then some of it enters our atmosphere, and we see it in terms of a stray meteor, a random meteor that flies in. That's different from the meteor shower that's boiled off a comet that we intersect that orbit. And so, if you go out and you read, I think you'll read people say that the parent object that's boiled out as material that's feeding the Geminid meteor shower each year is actually an asteroid, and that can be the case. But I think there's some debate about that. I think it also is possible that it is a comet that's dormant in the sense that its orbit has been altered so that it doesn't get close enough to the sun to boil material off anymore, but once did. I don't think we know exactly what that object is. But anyway, that's the basic idea for meteor showers that we see every year. And the Geminids are my favorites, as I said. And one of the reasons is they're medium slow, they're reliable. If you think of this tube of material, sometimes we hit the tube in one place, another place, or whatever, and it's a denser, richer pack of dust particles, and we get a bigger meteor shower, and sometimes it's a lesser meteor shower. The Geminids are very consistent year to year, I've found. And they're relatively slow, and if they're slow when they enter the atmosphere, that means you get bigger, brighter meteors. They look almost like they're rolling along and burning, and so you get a handful of really big, bright meteors in the Geminid meteor shower to watch for. And so let's just go ahead and talk about this. A little out of order of what I was going to do this, but to say the Geminids, you don't have to look at Gemini to see the Geminid meteor shower. What that means by the Geminids means if you trace where the meteors are coming from, they would trace back to the constellation Gemini. But Gemini might be over here, and you might be able to see the meteors over here and over here and over here. So you don't have to be looking right at Gemini. Now, it's great if the radiant, as we call it, the point you trace all the meteors back, they look like this, right? So there's Gemini, and the meteors might look like this, and you trace them all back, and they look like they're coming from a point right in here, and that's the radiant, is where they're all coming from in Gemini here. So you have that radiant where these meteors are streaking out away from there, and that's where our inner orbit is intersecting the orbit of this material, this dust material that's out there, and so it all enters the atmosphere and it burns up in different directions, but you trace it back, and it looks like it comes from Gemini. Now, most of the meteors you won't actually see in Gemini. You'll see in other constellations around Gemini, and trace back there, but it's good to wait until Gemini is up in the sky pretty far, because then you can see them in all directions around Gemini as well. And so I would say, for us, for me, here in Northeast Iowa, on the night of the 13th, as soon as it's dark, you should be able to start seeing meteors. And so 9 o'clock or 10 o'clock, it's going to be pretty well placed in the sky to see quite a few meteors. And so great to go out anytime. But 8:30, 9:30, 10:30 on the night of the 13th is great. And if you're a night person and you want to wait until midnight or 1 or 2 in the morning, it should be very good as well. The moon is very close to new, so we won't have any moon interference, meaning you can see fainter meteors. They're not being washed out as they come here. And you should be able to see a lot. You should be able to see meteor every minute or 2 or 3. So depending on how much light pollution, what kind of sky you have, you might be able to see a little bit more than that. So you should have a pretty good view of some really nice meteors on Sunday night. Use the week in advance, as I said, to look for stray meteors, random meteors that aren't coming from a single radiant in the sky, but just like this over here. Woo! It wouldn't be curved like that, but there you go. Don't want it coming from the same spot. So you got random meteors that are coming from different directions doing different things. Also, go ahead and work on finding the stars of Gemini. We'll talk about this more in coming weeks. This is a wonderful time to see bright stars in the sky. A lot of people know Orion. When I ask students in class what constellations they know, Orion is one of the top ones. There's the belt of Orion, the bright star Rigel, and the bright star Betelgeuse. If you draw a line from Rigel through Betelgeuse, you'll land up here just above the twin stars, Castor and Pollux and Gemini. And there's pretty good stars stretching down from those stars to make it look like they're twins, standing on the river of the Milky Way right here. So there's a hazy glow of the Milky Way, and you can see these twins standing on that Milky Way, Castor and Pollux. If you go the other direction, from the other leg star and shoulder star Betelgeuse, Orion, you go up past Aldebaran in Taurus the Bull that we've talked about a little bit before. And these are really bright stars in this part of the sky, and there are others that we will talk about. But that's your guide for this week. Go out this week, look for the random meteors earlier in the week, and practice finding Orion, Aldebaran, Castor, and Pollux. Castor and Pollux over here form Gemini. Gemini stretches this direction toward Orion from Castor and Pollux. That's where the radiant of the meteor shower is going to be on Sunday night the 13th. So go out, look for meteors that look like they're tracing back to this part of the sky. You should have a good show. You should be able to see it. I hope you have clear skies for it, and I hope you have a good week ahead. Take care, everybody.